Now let's talk about the second component, sugar. Right? Pentose sugar. In RNA, the pentose sugar is ribose. Right? That's where the R comes from. Okay? Now, this ribose has a structure like this. We have learned this in carbohydrates, but let me just refresh it for you. There are 5 carbons and an oxygen. It's a pentose. CH2OH. Right? Now, for the sake of convenience, because we want to avoid confusion between numbering carbons in the sugar and numbering carbons in the base, what is done is that we name these carbons as 1 prime 2 prime. So this is the first carbon right here, and I'll show it with a different color. This is the first carbon, right? And this is named as 1 prime. Why prime? Because we want to make sure we don't confuse between the carbons present in the pentose and carbons present in the base. This is the 1 prime. This one right here is 2 prime, 3 prime, 4 prime, and 5 prime. Okay? Now, in DNA, the 5 carbon sugar is deoxyribose. Okay? Deoxyribose. So let's draw the structure first. Let me draw the structure first, and then I will tell you why it is deoxyribose. So this is the sugar, 5-membered ring with OH on primary first carbon. OH, H, CH2, OH. So now this is the deoxyribose. This is just like ribose, except that on the second carbon, where is your second carbon? This is your second carbon right here, right? This is your second carbon, 2 prime, right? On the second carbon, there is H and H. There's no OH, which is why it's deoxy. No oxygen. Deoxy. So ribose without oxygen. So just like ribose, except for on the second carbon, there is no oxygen. So there is no chiral carbon. The second carbon is not a chiral carbon. So that's a difference between deoxyribose and ribose. So this is the second component, pentose sugars.